Thanks, Liz. Thanks, everybody, for joining us today. Today we're going to talk about getting started with tabular models, like Liz just introduced. And looking at that poll, looks like we have everybody's in a good spot for what we were looking for this presentation. It's really going to be an intro to tabular models. And so with those poll results being a lot of people who haven't used it at all, that's perfect. So again, my name is Brad Gall. I'm a senior consultant here with Pragmatic Works. We are a consulting company. We also do software for business intelligence products. And along with that, our consulting team runs some training as well. So we do some on-demand training that you can sign up for. We do on-site training and webinars like this and virtual trainings as well. So we hit the gambit of services you would need for business intelligence products. A little bit more about myself. I've worked with SQL, SharePoint, Microsoft BI Stack for over 10 years now. I like to speak at user groups and webinars whenever I get a chance. In my spare time, I pretty much spend most of that chasing rugrats around. You can see I have two little ones living with me and my wife. We recently actually relocated to Jacksonville. So we were in Cincinnati, Ohio, and just within the past 2 or 3 months now, I've come to sunny Jacksonville, Florida. I do blog occasionally on bradgall.com, and you can follow me on Twitter at bradgallsql. So if you have questions after this webinar, feel free to reach out to me via either of those avenues, and I'll also post the slide deck to my blog after this as well. So like I said, we are going to do an introduction to tabular models today. So that's our agenda. We're going to look at how we create a tabular model. And a tabular model is a model that we use in things like Power Pivot, in the new Power BI, the Power BI desktop, and also in SSAS tabular databases. All three of those products, behind them, when we create the models, they're all tabular models. It's really the same engine behind them. So for our agenda today, it's going to be an introduction to creating those. It's a really good skill for developers. Should all know this. If you're working in the data space, especially in the BI space, this is definitely a skill that you need to have. But for business analysts as well, I work with a lot of clients and talk to some business analysts that are still using Excel, and Power Pivot has really been around for a while, and Power BI has come out in the past year. It's an awesome tool set that a business analyst can take advantage of as well. So this is a really important skill as data keeps growing in our business intelligence environments for everyone to have. And part of the reason for me choosing this topic is there's been a lot of new stuff coming out. There's Power BI has been all the buzz lately, and there's lots of visuals and things we can do with that. But really the backbone of all this is building a tabular model for those visuals to run on. So I thought for this presentation we'd take a step back, get back to the basics, and really explain what the tabular model is doing to feed those visualizations. Along with that, we have pretty much a 3-point agenda. So most of this will be demos today, but I have a few slides to start us off with why we are using a tabular model. So why do we even need this new engine? Why don't we just hit straight up against the SQL databases we already have, or just using our good old Excel functions and pivot tables that some of us are used to there. We're going to look at some of the different flavors of the tabular models briefly. So I mentioned we have Power Pivot and we have Power BI and Analysis Services Tabular. What are some of the differences there between those? And then we're going to jump into the demos and build our first model. So why do we use a tabular model? A tabular model, first of all, we need to point out that these are analysis models. So these are models that we are going to sit on top of our physical data structures. So if we have a SQL database already, instead of just writing queries against it, this is a model that we would lay over the top of those physical tables. We could also pull in other sources like CSVs or some online sources in the case of Power BI. And we can put an analysis model on top of that. The reason we do this is it makes for a simpler reporting development interface. So we'll build out our relationships and between our tables, and it allows us to more quickly create reporting based on these models, because we're not having to write join statements. We don't have to write a lot of code really to get the data to interact with itself. It also provides faster reporting interfaces. So one of the things about Tabular is that it's built on an X-velocity engine, which we'll talk about here in a second, that makes the queries actually run faster than they would against our traditional SQL Server databases, and definitely faster than it can against, especially with a large data set just within our Excel worksheets. So how do tabular models really make the report development simpler? The models are defined in a GUI interface. When we jump into the demos, you'll see it's more of a GUI interface than some of the older traditional reporting interfaces like SSRS. So we can drag and drop and create our relationships, things like that. The report interfaces, once we've created those relationships, recognize them, and I put the kind of auto-magically filter our data for us. So we will drag and drop and create relationships. Then when we get into our report interface, those relationships will be recognized by the reporting tool, and as we create a slicer or a filter on our report surface, it'll automatically filter other parts of our report. We don't have to go write a bunch of different SQL queries to just pull the data we want. We don't have to create our own SQL query per parameter like we used to have to do in SSRS. All that's done by the way the engine looks at how we've related the data together. And then another advantage of using the tabular models is that they are the query language is called DAX. And DAX is a function-based language that was written by Microsoft to be very similar to what you're used to in Excel. So if you're an Excel business analyst and you're used to your if statements and some of the other just functions that we use a lot within Excel, the language for DAX within the tabular models is very similar to that. So we'll see some of those in our. I'm just going to do some real simple functions within our demos just to get you started, and you'll see how easy those are. The nice thing about DAX, though, is that we have that nice short learning curve to get us going. The language itself is actually, though, powerful enough to provide pretty much all the capabilities you'll need. So I've seen some clients that have done some really sophisticated stuff. We've helped a lot of clients do some really sophisticated stuff within DAX to get some pretty robust aggregation formulas built within a model so that their users are able to then drag and drop and create reports as they need with a lot of business requirements built into the aggregations that are running behind them. And the faster report execution piece of a tabular model comes from the back-end engine that's running these. So all three, even the desktop versions, the Power Pivot within Excel, the Power BI, and the tabular databases are all running on an X-velocity engine. And an X-velocity engine is really just a fancy word for a data engine that is using a lot of compression, and it's storing the data in you could say, a fancy way of columnar storage. Really all that's to say is it compresses the data down 10 to 100 times compression, which makes reading the data faster, and the columnar storage is structured in a way that's fast for reads and fast for aggregating of data. So your traditional databases are really built for inserting data and maintaining high integrity of the data. When we put the tabular model on top of that, the reason we do that is for reading. The whole purpose of everything we're going to do here today is for analytics and reporting, and this engine is built specifically for that. Now the flavors of tabular models we have available to us from Microsoft are really three right now. So the space has been kind of confusing and hard to navigate over the past 4 years since it's come out. There's been a lot of change. The product has evolved quite a bit, and there's still those different streams, you could say, of ways you could develop tabular models. So when it first came out, we've had the server version, the SSA is tabular since the beginning, and we had that in Excel. And if you look at the differences there, the top line is where we would develop the tabular models. And within Excel, we would build them within a Power Pivot add-in right there within Excel. We could add that add-in. It comes built in now with Excel 2013 and above, and we could start building a model right within our Excel documents. With SSAS Tabular, we used Visual Studio, and we could build it. It's a very similar interface, and we would build out those tabular models. Within the past year or two, Power BI has come out as a standalone desktop app separate from Excel, and that's where we'll build the models there. We're actually going to use Power BI today to do our tabular model. Now for the collaboration differences between these, with Excel, if we wanted to collaborate and share the models that we created with multiple people, we had a couple options. We have a couple options today. So previously we had just SharePoint. We could enable our SharePoint farms to be able to deploy Excel files and share them there. Recently with the PowerBI.com, as it has evolved, we can now actually save our Excel Power Pivot models into PowerBI.com and share them that way too. So we have both approaches available. If you have SharePoint on premises, you could deploy there. If you don't have that yet, we could go to PowerBI.com. With the Power BI desktop app, we can deploy up to PowerBI.com, and that's how we do our collaboration there. And it's a very robust interface there with how we can share those and create dashboards off those, and lots of cool features out there, a lot of which we've talked about on previous webinars here with Pragmatic Works. With Analysis Services Tabular instance, the way we share it is it's already a SQL Server instance of itself. So the reason you actually go and start upgrading and doing an Analysis Services Tabular databases versus one of the Excel or the Power BI versions is that you want a larger audience to hit it. And as the third point says there, one of the advantages of doing that is we can take advantage of server hardware. We can build in some more advanced security as well. If we go back and look at the desktop versions again, with Excel and Power BI, some of the reasons you'd go with either, really at this point the only reason you're going to stick with starting in Excel is if you're familiar with Excel and you just want to stick with that interface, or if your end users are really just telling you that they want to have Excel. They want their data in Excel, that's what they're used to, they're not interested in another application. That's why there's Power Pivot within Excel. If you're starting off new, with a lot of you guys are today, it sounds like Power BI is going to be probably the path that I would highly recommend that you start with. It's the latest and greatest. They're updating it frequently, and by frequently I mean every month. It has the most data sources available to us to pull data from. So Excel has a lot. There are a lot of sources we can pull from Excel. Power BI is coming out with new ones every month. And then the new features are also being deployed to Power BI that don't exist yet in the Power Pivot for Excel. So one of the big ones is bi-directional cross-filtering, which is a little bit more of an advanced topic. I'm going to show you a little bit of that in the demo today, just mostly so that you don't get hung up with a common error message there. But that feature is there, and as you advance your models, it's going to be one that you want to take advantage of. So if you're starting off today, wanting to get into a tabular model and some self-service BI, I would definitely recommend we start with Power BI for that. So next we're going to build our first data model. So we're going to jump into the demos here. Before I do that, I just want to step through a high level of what we're going to do to build our first model. So really it's 5 steps that I've kind of broken down of areas where we'll iterate through these steps. As you're building your models, you'll find that you iterate through these, pull in more data, build more columns, build more calculation on those. But this 5-step, the 5 steps that you incorporate are you're going to connect to your data sources. So the first step is going to go connect to your data source and import your data. You got to get your data into your model before you can do anything with it. So again, this is a model that sits on top of your physical structures. We have to go to those structures and pull the data into our tabular models. Next, we're going to create a logical model. And really this is where you'll see in the demo we're going to relate the different tables that we pull in together. Again, building those relationships between the tables makes it so that as we're interacting with the data, the reporting interfaces filter the data for us automatically. It makes it so that we don't have to write a lot of code. It's the piece that writes a lot of code for us. Then to make our models more robust from there, we're going to create calculated columns. So we're going to derive some new data out of the data we already have. So a lot of times what we'll find is our source data doesn't necessarily have the data exactly like we want. So in our example, it's going to be a classic one. We have a last name field and a first name field. But really on our display, we want to combine those together. Using that DAX, those DAX functions, it's pretty easy to create a new column, drive a new column, and add that to our model so we can use that within our report interface. Next, since what we're trying to do is analysis on our data, we're going to create calculated measures. So with calculated measures, those are built for aggregating data together. So the classic example of that would be the summing up our sales. We want to not just see what the sales were for a particular day, we want to have some kind of aggregation. Generally, we start with the summing of the data, and we want to sum it up over the different fields that we have. So that's where we'll use our calculated measures. And that's really where the power comes in that we're not going to get too far into today, but it's a good thing to know that we can start simple, and with these calculated measures, we can do things like 12-month rolling average, year-over-year growth. We can do a percent of total calculations, all on the fly for the user just by building some calculated measures in our model. And then lastly, build some reports, so display our data. So once we've pulled it in, we've related it, we've added some new derived and aggregations, then we're going to display the data on the canvas. So with that, let's jump over to some demos. There we go. All right. So I'm going to open up Power BI desktop, and we're going to play with some baseball data that I've downloaded off the internet today. So on my last slide, actually, I have links to where we can go download Power BI desktop, and actually where you can get the same data that I'm using for these examples. So there's a website out there that has some free baseball data that we can play with if that's something that interests you. And you want to follow along with this afterwards, you can do that if you so wish. So I opened up Power BI Desktop. I went and closed the splash screen. If we're following our 5 steps there, really we're just going to go through the first 4. The first thing I need to do is go get some data and pull it into my model. So just to get a little bit of a landscape of where we are within Power BI Desktop, I'll give you a quick tour. So up here at the top, we have an Office ribbon bar, very similar to what you're used to in all the other Office products. It's the Microsoft way now is to go with their ribbon bar. To start things, under this external data area of the ribbon, these are all the different ways we can pull in data. We're going to keep it simple today and just do a get data and pull it from a SQL server. If you don't have a SQL server to play with, you could use an Excel file as a source. That's an easy one to connect to, or CSV files as well. The data that I'm using today can be downloaded as a CSV file, and you can connect to it and play with it. So we have some options up there. That's really where we're going to get started for our step 1. Just to give a little bit more of a tour, though, over here on the left-hand side, these 2 buttons right here will switch the interface in our IDE to be where we create our relationships, and then where we build our derived columns and our calculated measures. So as we click on these 2 buttons, once we've pulled in some data, we'll see those 2. We'll see the table relationships and how we can relate them together, and then we can go see our actual data and build some derived columns, aka calculated columns, and build some calculated measures there. This last button at the top is where we build reports within Power BI. So again, we're going to focus on the first 2 mostly today, but we're going to bounce over to the reports so we can see our data as we're building it out and see how things are looking there. Just to finish the tour, over on the right side, let's try that again. Over on the right-hand side, my zoom is acting up a little bit. Over here on the right is, yeah, my resolution's off, sorry. I won't be able to zoom in, but over on the right is where all of our visualization activity takes place. So this is where we can pick our different visualizations. Again, it's something you can play with, and we have lots of webinars that show you how to use those different features over there. But just to point out, if you're brand new into Power BI Desktop, this is where we build our visuals on the report canvas, is with the stuff over here on the right-hand side, the visualizations, the filters, some field lists that we'll see once we pull in some data. So the first thing we're going to do is pull in some data. Let's go grab Get Data up here at the top. If I click on that, we see we have a lot of, it gives us what our most common data sources are. If I click on More, though, Just want to show you the variety of sources we have available to us. So if we click on the All tab here, you can see all the different sources we have. We have Excel, CSV files. We can go filter through a folder list and do some metadata off files if we want to. If you're say in infrastructure and you want to go just pull some data off of some files that are sitting on a file server, you can see like the modified dates, create dates, things like that. We can pull from SharePoint folders and look at the files there. Oracle, pretty much all the major database systems you would want to connect to are all available to us. Azure is something that is on the horizon for a lot of companies we work with for sure. We can connect to all the different Azure sources we'd want to. So Azure SQL Database, SQL Data Warehouse, HD Insight, all those connections are built in for us. We can connect to Active Directory. If you're an Exchange admin, you can go connect to that. So you get the point. There's lots and lots of different data sources we can pull straight into Power BI. We're going to keep it simple today and just pull from a SQL Server database. So if I click on that SQL Server, let's try again. So I'm going to click on SQL Server. It'll pop up in a dialog asking me what server to connect to. So I have a local server running on my laptop here. And you have two options to point out. Today we're going to stick with import, which is going to import my data into the model. And that's what's going to take advantage of the tabular model that gives you that X-velocity engine. If you're so inclined, we could do direct query. It's more of an advanced topic, whether or not you'd want to go through those two things. Starting off, I would suggest just sticking with the import option. So we're going to stick with import. I'm just going to give it the server name. I'm going to click OK. And this is going to pop up a navigator showing me all the different databases I have available on that particular server. We're going to go grab from a database called Baseball Lawman 2014, and I want to pull in 3 tables out of this database. So let's go grab, I have some batting data, I have a table called master, so the master table actually holds all of my player names and some information about my players. And then lastly, I want to pull in teams. So I have some table that holds the teams information. So I'm going to check those 3 tables, and I'm just going to click on load down here at the bottom. So again, we could click on edit, and this is another topic that you'll see hit on other webinars. That would launch Power Query. So Power Query is something that's built into Power BI Desktop. There's also a version of it for built into Excel that you can use with Power Pivot within Excel. And that gives me the ability to do some like ETL type tasks before I even get the data into my model. So the key thing for you to know as you're starting off, if I just pick this source here and I click load, it's just going to load the data right into my model for me. I do have the option where I could edit some of that before I even get into my model, and that would be Power Query. So we'll click on load. It's going to go out and read my data source. You can see it's creating connections, and what we should see is the row counts as it actually pulls my data and populates it into my model. Now if we click on our relationships button on the left-hand side for our second step, we can see it's pulled in our 3 tables. So you see the 3 tables that I pulled in from my source. So I have a batting table, I have a master table. It's already created a relationship for me there just by looking at my data, and I have a teams table. Now if we take a look at this relationship, it may or may not have created it for you. What it tries to do is look at your data and see if there's columns that match in name and data type and that are a correct cardinality for creating a relationship between these 2 tables. It just so happened that it did find excuse me, the relationship for me in my data. I'm just going to delete this and show you how I would create it if it did not find that. So if I was pulling from 2 sources and maybe the 2 column names didn't exactly match or something like that, the way I would relate these 2 things together, so this is my batting data, this master table is actually my player data. I could pull player ID over to player ID on master, and it'll create the relationship for me. So it's a drag and drop interface, and we can relate our tables together. Right now I'm actually not able to relate teams and master, because what you'll find is if I try and drag team ID over, to batting, so batting is what I would want to relate my teams to. I will get an error, and it's telling me we cannot create the relationship because there's missing intermediate data. Really what it's telling me is it's read my data, it can actually read the cardinalities of it, and it knows that I have multiple team IDs duplicated on both sides of that relationship. And it knows that's not going to work. It doesn't know how to relate 10 teams with the same ID over to 15 teams with the same ID on the other side. The way we're going to fix that here in a second is actually what I need to do is connect team ID and year ID together, concatenate those two fields together. That would give me a unique column that I could then connect batting and teams together with. So we'll do that relationship here in a second. But that's, if you get that error, that's what it means. It's something, it's reading your data and telling you whether or not this is a good idea and whether or not it can create that relationship there or not. So with that built, let's go into our, so we have the one relationship we're going to start with between batting and master. Let's go up to our modeling button here. Look at our data, and we can see on the right-hand side, let's see if zoom it will work. And not quite. Sorry about that. Hopefully the resolution's not too bad. Over on the right-hand side, I can click and open. I can see all the fields that it's pulled in for my tables. So I have a batting table here. I have a master table here. Again, master is all of my player data. And one of the things I can do to make this easier for other people and really easier for myself to navigate going forward is I can rename pretty much anything, any column or any table after I pulled it in. So just because it's called master in my database, I really want this to be called players here. So I just give that a new name. It updates automatically there. So we're looking good. So now we can see we have batting data, we have player data, we've related them together. And I want to give, add some new columns to my player table. If we look at this closely, I have a first name, I have a last name here, and I have a given name. Given name is not exactly what I'm looking for how I want to display this. I really want to combine first and last name together. I don't have that column anywhere else in my data, so I'm going to go ahead and create that. So this would be a calculated column. I'm going to add a whole new column to this table within my tabular model. To do that, I can right-click on the player table name, and I have two options. I have new measure or new column. Again, I want to add a whole column to this data set, so I want it to give a result for every different row within my table. So I'm going to do new column. And it launches a new column, and it launches my formula bar. Again, very similar to what you see in Excel. So it started the formula for me. It's calling the column, and it's just column equals, and then I'm going to give it an expression to populate this column. So we're going to call this full name. That's going to be my column name. And what I want to do is combine together the first and last name, and to do that, the syntax within DAX is pretty straightforward. The table name is always going to go within single quotes, and the column name is always going to go within square brackets. So anytime you're referring to data within your model, that's how you navigate to it. Single brackets around the table name and square brackets around the column name. So we're in the players table, so that looks good. We also get a nice autocomplete feature here. If I just hit tab, it'll autocomplete. I'm going to open up the square bracket, and I want to put first name or last name first, so I know that's my first column. If I just put the ampersand sign, I can add the second column. So again, we're going to navigate to the players table, open the square bracket, and the column I want to combine it with is name first. If I hit enter there, after I hit enter, you can see, no, not quite. Hopefully you can see that it's created the table, populated it for me, and showing me what the data looks like from my formula already. So this is where the speed comes in, where it can do these things on the fly as we're writing it. It doesn't quite look like I want it to look, and actually I can tell I made a big typo where I put the first name both times. And really once it's, I'm going to correct the last name there, but I also want to put a comma between those two things to make this look a little bit better. So to do that, let's go up here, and I'm going to fix this first. So I don't want name first, I want name last. So we'll fix that. And then to add the comma, I'm just going to add another double quote string with a comma and then another ampersand. So what I end up with is first name, concatenate the comma, and then concatenate the last name. And actually, sorry again, I'm going to switch these real quick. Last name, first name. So now we can see that's looking a lot better. Now we have our last name first with a comma, and then our first name. Let's fix that up real fast. Let's take a look real quick over on our report interface and see how that is working for us. So if I switch over to my report interface over here on the top left, I have a blank canvas. I mentioned we weren't going to spend a lot of time here, but we are going to just kind of look at our data and see how things are building up as we're building things. So I built that column in the player table, so that's where I'm at in my field list. You can see actually it gives a little function expression sign next to my full name column telling me that that is a calculated column that I've created here. So I'm just going to check that. It's going to create the table for me over there. I want to turn this into a slicer. So to do that, I'll just click on the slicer button under here under visualizations. And then just to have some data to play with, I'm going to grab my batting table, and I'm just going to grab hits off my batting table. So I'll click in the white space again, click on hits, and I want to see this over time. Doesn't make sense to look at all the hits ever. And so I'm going to throw year ID onto my axis. So for Fred Abbott, you can see how many hits he had by year. If I uncheck him, we'll see all the hits of all time. You can see how fast that's running there too. If I check any of these people, it'll filter down. I can check multiple people as well. So that's looking pretty good. We have first name, last name, and we can filter the data for hits down by those guys just right there. So let's do the next step. So we've created a calculated column now. We've extended our model a bit by adding some derived columns there. I want to do some aggregations on this data now. So let's get rid of this. And actually one thing I know that my users are going to want to do before I even do that is they're going to want to slice this by teams as well. So let me go grab teams over here. I want to grab the team name and I want to throw that onto my canvas and turn that into a slicer as well. So I drug it and dropped it over onto my space, and I'm going to click the slicer button. And when I click on this, what you're going to notice though is that it's not working. So when I click on Baltimore, Maryland, or I click on the Buffalo Blues, California Angels, my data is not filtering for my hits from my batting table. So my hits came from my batting table, my team name came from my team table, nothing is filtering over here. And that comes from the fact that I haven't related those two tables together. So I mentioned in the slides that we relate the tables together and then everything on my report interface interacts by reading through those relationships. Well, we have to go create that relationship. So let's go do that. Before we can do that, I have to create that derived column on those two tables that I can use to link together. So we're going to do that. Let's go to our batting table and our team table and create a column that we can use to link the two tables together. So we're going to use year ID and team ID on this. It's going to be a very similar formula that we just did for the full name. So I'm going to go through it fairly quickly. I'm going to right-click on batting. I'm going to say new column. We're going to call this team year. And it's going to equal the batting team ID. And we're just going to concatenate it with the batting year ID. Just hit enter on that. You can see we have our concatenated column there on the right. I'm going to do the same thing on my team table. So right click on that, do new column, do team year equals, this is going to be from the teams table. And this will be team ID, ampersand, teams, and year ID. So So again, concatenating team ID and year ID together into a single column. Now we have it. We have those two calculated columns in both tables. If I now come back to my relationships, I can relate those two tables together with that new column. So we got the error before, but now if I link these two together, I get no error, and I have a relationship between the two. So it looks great. Let's go back to our report and see if that fixed our problem. If I click on a team name now, click on the Cincinnati Red Stockings, yep, perfect. So now we have that relationship there. The data is that those two tables are related together. I can do aggregates and filter across those two tables with that relationship there. So that fixed up our slicer for us. Now with that done, I want to jump over and go to our fourth step in our building up of these tabular models. I want to create some calculated measures. Now what I initially did there to get some data flowing is I just drug hits over and put it onto my report canvas. And you can see on the columns on the right we have those little sigma signs next to a lot of our data. And really what that is that the tabular model has read the fact that these are numeric fields, and so it just assumes that we want to sum them up, and it gives us an implicit sum on those columns. That's great and fine. It does that nice simple sum for us. If we want to control that ourselves or do something more robust, we can do that ourselves with a calculated measure. We could do it right here in the report interface. That's something they've added recently. Just to make it more clear, I'm going to switch back over to our data tab again, and we're going to go to teams this time, or let's do, yeah, we'll do teams, and we're going to aggregate. So we had some data on the team table itself. We're going to aggregate that data up. So we're going to do a sum on the, let's do a sum on strikeouts and a sum on walks. So we're going to do some calculations on those. If I right-click on teams, instead of doing new column, this time I'm going to do new measure. You'll see it throws it at the bottom. Since it's not a column, it's not going to show me the data right away here within the data space. But I do have the same formula bar at the top. So I'm going to call this total strikeouts. And for this one, I'm going to keep it simple and just show that we can control this. We're just going to do a sum aggregate, and we're going to do a sum of the team strikeouts. So SO is the data there. I'll close paren on my sum, hit enter. And I'm going to switch back to my report just so we can see this. Select my bar chart. I'll delete the hits that we had there off of it and go down to my teams, find my total strikeouts. So you see there's a little calculator icon next to that one telling me that it's a calculated measure I've created. I'll drag that to my values. Now I can see the strikeouts by year for the different teams here, or also by the different people as well. Now with calculated measures, that one again was pretty simple, pretty basic calculated measure. What we can do with those though is they get more sophisticated, and we can actually build them on top of each other. So build them up on top of each other as they go. So if I go back to my data model here, I have total strikeouts. What we're going to do is create a ratio and see what my strikeout ratio was compared to my walk ratio. So I'm going to follow the same format. I'm going to right click on teams. I'm going to go to new measure. And we're going to call this one total walks. And this will be the sum of the team table. And it's going to be W for this one, or I'm sorry, base BB for walks. Hit enter on that. I have too many parentheses there, so I'm going to take one of those off and hit enter. Oh, sorry, I used the wrong bracket. That's what it is. So fix that. There we go. So we need the square brackets around that, and we're doing a sum on that. So I have total walks and total strikeouts. what I can do within a calculated measure is I can refer to other calculated measures and build them on top of each other. So now if I want to do a ratio on that, I can do a new measure. And for this, I'm going to call it strikeout to walk ratio. It's going to be equal sign. And if I just hit the square bracket, you can see the two calculated measures I've already created pop up as my IntelliSense there. So I'm going to do strikeouts, and before I do that, I'm going to use a divide function. So one of the functions that is available within DAX is the divide function. So I'm going to divide my strikeouts by my walks. Hit enter on that. Now let's go back to our report and see what that data looks like now. So we'll take off our total strikeouts. We can see that my total strikeouts, my strikeout to walk ratio is here in my list. If I click on that guy, let's get some data that's actually got some data, like New York, somebody like that. I now see my strikeout ratio over time of strikeouts to walks for that team. Looking pretty good. Now if I wanted to see that data formatted a little differently, maybe I want to see this as a percentage instead. So I want to see if we have 300% strikeouts. We handle that in our model as well. So the formatting of our data, the way it shows up within the report, is actually handled within the model itself. So that way, anytime someone references that calculated measure going forward in a report, we don't have to keep resetting up the format of that. So if I go back to my model again and I go highlight strikeout to walk ratio, if I click on the modeling tab up here on the top, right here, and under the formatting tab, I have some options that you'll see pretty much, if you're used to Excel, same things you would find there. I'm going to switch my format to percentage. It's going to switch it to a % sign and 2 decimal points. So let's go back to our report and see what that looks like now. So now when I hover it over it, you can see it's 317%. This data might not make 100% sense with that, but you get the idea. We can set the format. We can make it currency if we want to, things along those lines. So one last thing I want to do is I want to pull in, so we've gone through our 4 steps. Again, very basic just to get us started. We've pulled in some data, we've related that data, we've added a calculated column to the data, and we've built some measures within our data. Those are really the 4 key steps that you need to build the model. Again, when you do it yourself and do it with some real data, it's going to get a lot more complicated than that as you go, and you build this to be more robust. So the scenario we're going to play out right now is that data looks great. I've got this new data source now that I want to pull into my model that I already have, and I want to relate that to the data I have here available. So we're going to do that. So if we go back to our home ribbon up at the top, we are going to go to get data again, and it could be from another file. It does not have to be from the same database. I could pull in an Excel file, for instance, and relate it to the SQL data I have here. For my purposes, I already have it in a SQL database, so I'll go pull it from there. And again, it's from the same database for me. We're going to go pull in some salary data, and we're going to load it. Should see it load and pull in some rows. I'm going to go back to my relationships tab here, and we can see it popped in and it related itself to players because we have a player ID column there. So it found that. Again, it did not relate to teams. So just like we had with the batting, we need to create a quick derived column so we can relate it to our teams. So let's go ahead and do that. If I go back to my data tab and I go to my new salaries table, we're going to create a new column. We call this team year again. It's going to be equal to salaries, team ID, concatenate with salaries year ID, and enter on that. We have our column. Let's go back to relate it. So we have our team year. Let's go relate this to our teams. Drag this down. and boom, it created a relationship for us. Now one thing, for sake of time, instead of showing you that the data is not going to relate correctly, I'll just point out that we have a dotted line here. What that's telling me is that relationship, it created it, but it actually left it inactive. Now if I went to my report interface and I tried to relate some salary data to some team data, it's actually not going to relate to each other because that relationship hasn't been set active. So why did it choose to do that? If I go and double click on any relationship within my model, I can go look at some of the settings I have here. There's three really settings. Well, there's four. So first is what two columns are these two tables related on? So team year, like we did with our drag and drop. Cardinality it found for us. Cross-filtering direction, I mentioned, is something that's in Power BI Desktop and is a great feature that you're going to take advantage of as you get more data. It set that to single, which is fine for our purposes. Make this relationship active, though, is what is not quite right. When I go to check that, what it's going to tell me is that you can't create a relationship between this because it would create ambiguity between the two tables, between the teams and players. So this is something I see people run into right away, or run into a lot when they first get into creating these models, especially if we're not starting with a nice pretty star schema or something like that. We might be pulling in data and having some circular relationships is what's going on here. So what it's telling me is that there's ambiguity between the teams and the players table. If I cancel out of that, something I want to show you is on these relationships we have these little arrows on all of them. So we have two arrows here, we have two arrows here, we have a couple there as well, and we have one there. What that's telling us is that whichever way the arrows point, a column from salaries, for instance, is able to go this way and filter data on, I believe that's my players data. The players data is also able to go and filter data on my salaries field. With the teams, because the arrow is just going towards the teams, team columns actually only filter the salaries, but salaries will not filter the other way. So that's the way the filtering context can flow through. Where it's important when you're starting off is I'm not able to relate this. The reason being is that salaries, or teams is actually already has a means to get to salaries. So we follow those arrows and we look at these relationships. Teams to batting has a double arrow there, meaning that teams can filter batting, batting can then go filter players, and players can already filter salaries. That's where that error is coming from, because it can't create two relationships to the same table. If there's a path already from teams to salaries, it's not able to create another path from teams to salaries. If I wanted to have that direct relationship there, in this model it's pretty easy to fix. I could take off this cross-directional. If I set this to single, it filtered that. Actually, we'll set this one to single. Sorry about that. And I might have gotten the wrong one there too. Let's try this again. And now we're good. So now I have a relationship going from players to salaries, teams to salaries. We fixed that circular reference basically to salaries. I just have a couple minutes left. What I wanted to do is create another calculated measure between salaries and teams. So let's do this. Let's go and I broke my relationship there. Let's fix that. So players goes to salaries. I won't worry about that right now. Basically, I switched my filtering context around the wrong way. Can do that. And broke that. But let's fix, what I want to do for this last measure is do salaries to teams. So as long as I have this relationship, I should be good there. I can delete this one off even to finish out our demo. Teams filter salaries. So we're going to go back into our data and we're going to go to our salaries table. And what I want to do is create a calculation, so a new calculated measure. And for this one, I want to see how much am I paying per hit. So this data has salary by player, and I have hits per team there in my data as well. So I'm going to create a calculation to relate these two things together. And I want to say how much am I paying in salary for every hit that I get as a team, and see what that data looks like. So we're going to call this dollar per hit. Dollar per hit. It's going to equal division of the sum of my salaries. So salaries table, the salaries column, we're just going to do a sum on that, and we're going to do a sum of the team table hits. And if we close out the divide function, so we have, with this calculation, we're just doing a sum on our salary, a sum on our hits, and dividing the two. And we go back to our table here. Let's take off the walks to filter hits ratio, and we got teams there. I'm going to take the players off because that's not relevant for the data we're looking at right now. And if I expand salaries, I can throw dollars per hit on my screen. And I screwed something up somewhere in my demo. Let me look one more time real quick, otherwise I can pop open a finished product of it. I must have did something wrong with one of my calculations. What I can show you is what a final product looks like. And I'll put this on my blog site too, a final copy of it, if you'd like to see it and play with it. But what we should end up with is something like this, of dollars per hit, where I can select the team name, and I can see how much dollars I spent per hit per year. And that's based off of my calculation here for dollars per hit, which should be on my salaries table. So I'm not sure what I did wrong with that calculation, but that's how it should turn out if you follow what I put into the Power BI that I'll put up on the blog site. But you can see I related those two tables together. So I pulled in some new salary data, took the hit data I already had, related them together, and built a ratio out of that. So I can continue to add and create new relationships and pull more data into these models as they go and keep growing. So that's all I had for the demos today. Hopefully it was a good jump start for you if you've not been worked within a tabular model yet. I can open up for questions now. I just want to throw up here in the slide deck. Also, there's the two resources I had for today, like I told you. If you just go to powerbi.com, pretty much that's the only site you really need to hit. That'll give you the download for the Power BI desktop. One thing I may not have mentioned is that Power BI desktop is completely free to start with. All you really need is an email address. It just can't be a Gmail or a Hotmail email address, and you can go download that for free. Actually, you can download it for free. You can play with the powerbi.com site with an email address. And then the demo data is data that's freely available that I just pulled off the internet to play with. So did anybody have any questions? I can go ahead and open up for questions now for the last few minutes we have. Let's see here. Let me open up my questions window. Give me one moment to get this opened up. All right, lots of questions. Let's see here. Can you update import on a routine basis? Yes. So what we did during development was import the data while we were developing. You have to deploy it either to SharePoint or to PowerBI.com as the method going forward. Once you put it out there, you can set up as a schedule to refresh the data. And that's part of the collaboration piece of the tabular models. With the server version, you can also, it's called processing the cube. It's processing the database. You would set that up with your SQL schedules. Can we pull data from Microsoft's APS data warehouse? Yes, absolutely. That's one of the sources you can pull from is the APS data warehouses, and you should be able to pull that into your Power BI models. Let's see here, another question. Does tabular model work with many-to-many relationships? So I just touched on that a little bit today. That bidirectional filtering is how it handles many-to-many relationships now. So in the Power Pivot Excel version, it does not handle that very gracefully. You can get around it with some DAX formulas. But with Power BI and with SSAS Tabular 2016, which comes out in a couple weeks, both of those will handle bidirectional filtering, aka many-to-many relationships. On the screens, uh-oh. Looks like I was having some issues with the video and did not see that. I apologize for that, sorry. Hopefully most of it was able to be seen. So question, how can I change the summarized property of a field, say from sum to average or from sum to do not sum or average? So you can handle it yourself with the calculated measure we created. That's the way you can change the summarize. I can show you also very quickly the way you can manage the implicit calculations, so the ones that have the sigma sign next to them. If I go back to my model here and I click on, let's go to batting, let's pick one at random. You can actually control those default aggregations that it creates for you. If you click on the modeling tab there, up on the top when you have a column highlighted, you can see the data category. That's something you can play with. You can tell it it's a state or a city or things like that for the maps. The default summarization is where you control how the default sum works. So it defaults to sum if it finds a number. If I click on that though, I have a few options. I can tell it not to summarize it, or I can tell it to do one of the other basic summarizations if I want to. So we have a few more minutes. I'll hit a few more questions here, and if I don't get through all of them, I'll post a few to the blog that I don't get to as well. So how do I create an aggregation on the report level which would not be attached to any table? Rather, it has a complex aggregation that references multiple tables. You would actually create that the same way with the calculated measures. Is kind of misleading that you create the calculated measure on a table, because it gets a little more in depth of the inner workings of DAX, but the context of a calculated measure really doesn't matter which table you put it on. So you could put it on, you could just import a table that's blank and put calculated measures on them if you'd like to. Otherwise, you could just put it onto the table that really it makes the most sense to the end user for it to live under. It doesn't matter which table you put it under, you can still aggregate the data from all the different tables by using the sum functions. Is there a maximum limit to the number of rows that we can import? No, there's no limit that I've hit yet. There's a limit for the size for Power BI desktop there's a limit to the total size that we can upload to powerbi.com. Right now, as it stands, the last I checked at least, it was 250 megabytes. You have to remember though that it compresses your data quite a bit, so you could get probably 25 gigabytes of data compressed down into this. With the tabular server version, I've seen some people compress a terabyte of data down into a model and have it run within the memory space on an analysis services server. So you're just bound by the server hardware at that time. Yep, that's a few of that. Let's see if I have any other questions. May have time for, I'll do one more question. Maybe two. So compound primary key is allowed for tables. So not natively, but we did the derived column to handle the compound primary keys. Let's look for one more. Can we set global filters on Power BI? Also, can Power BI propagate flyer selection to other selections? For example, if you filter data by country and choose if you select another filter, is the data already filtered by the country selection? So yes, one of the things that Power BI is really good at, where it excels over some of the other Microsoft reporting tools, is that the report interface is fully interactive. So you might have seen it when I was clicking around a little bit earlier. If I had another slicer here and I click on Kansas City Royals, it'll filter the player list to just Kansas City Royal players. And we actually have some control over that. Again, if you look at some of the other demo videos out there on the free trainings for Pragmatic works, believe Devin or someone has gone through how we can do the visual interactions, control which components on the surface control which other ones, how they interact together. And then can you set a global filter? That's again part of the visualizations, but over here on the right-hand side, underneath visualizations, you can see that there's a filter section that we can use. And that's not working still. But you can filter for the whole report. You can filter for one tab in the report, or you could filter just one visual within the reporting. Unfortunately, I think that's all the time I have for today. I do see a couple other questions. How to create the rolling 12-month period using DAX. That we would use a calculate function for. If interested, I might try and put that out as a blog post. It's something I could probably put out there pretty quickly. Or I know there's a lot of other people that have blogs out there on that as well. But thank you guys, everybody, for sticking with me through this. A few little technical difficulties I had there. Hopefully everyone was able to see most of it at least. And if you have any questions, feel free to reach out, and hopefully you'll join us again too for some more free training on the T's. And for the links, so if you just go to, somebody was asking for the links, I'll put them up just to finish it one more time. And like I said, if you just go to bradgall.com, I'll post the slide deck up there by the end of the day today and have it available so you can have the links to click on as well. Thanks again, everybody. Hope everyone has a good day. I'll talk to you later.